All right, guys, good morning. Today, guys, we're going to look at how to write electron configuration. All right, so in your previous class, you should have learned about, what the big one means, what the S means, all that, the exponents, all that lovely stuff. Okay, and then I should have taught you how to write down electron configuration. Now, today, I'm going to show you the shortcut, okay, the shortcut on how to write down electron configuration using this periodic table that you see here right in front of you. All right. So guys, again, electron configuration is just a way of distributing the electrons around the atom. We know now, based on Bohr's model, that remember electrons are in different energy levels. They are in orbits. All right. We know now they're not really in orbits, but electron clouds, but they do still have certain energy levels. All right. So we're going to look at how these electrons are distributed, all right, around the atom in these energy levels. All right. So if you look at the periodic table right here, I have shaded a few things. All right. So if you look closely, this column right here, the second column right here, okay, group two is shaded. Okay. This one right here is shaded. Okay. This one is shaded right here. And this one is shaded right here. Okay. So guys, when we write down electron configuration, we're only going to write down, guys, the electron configuration in those shaded boxes plus our target box. All right. So basically, what we do is we go box per box until we hit our, uh, the atomic number that we want. All right. So let's go straight into the example. For example, guys, we wanted to find the electron configuration for Mg. Okay. Mg. Okay. All right. So how do we do this? So first of all, let's find our target box. So our target element is right here. This is the target box that I was talking about. Okay. All right. So we want to get there starting from number one. So if you look closely, the atomic number for Mg is 12. So you got 12 electrons, right? 12 electrons. So we want to get from 1 all the way to 12. Now, we go box per box. Again, you only write down those in the shaded box. So look at H. Okay, look at box 1. Is it shaded? No, so you don't write that down. Okay. How about box number 2? Is it shaded? Yes. Therefore, I write down the electron configuration inside that box. So if you look closely, it's 1s2. You see it? All right, keep on going. How about box number 3? It's not shaded, so no. Box number 4 is shaded, so yes, I need to write down whatever is inside the box. It's 2s2. Right, keep on going. 5, no, it's not shaded, so I don't need to write it down. 6, no. 7, no. 8, no. 9, no. 10, yes. It's shaded, so I need to write that down. So this is 2p6. Okay. 11, no. 12, since 12, guys, is our target box, we need to write that down. So again, you have to write down the electron configuration in your target box. So this is 3s2. And that's it. That's the electron configuration basically for magnesium right there. And again, how do you check? You can actually add up all the exponents here. So if you add up all the exponents here, you add up 2 plus 2 plus 6 plus 2. It should give you the atomic number, which is 12. That gives you the 12 electrons right there. Okay. All right. So again, by the way, guys, I know there's 12 electrons because again, the formula for electrons is atomic number 12 minus the charge, but since there's no charge, it's equals to 12. You see it? All right, let's try it out again. Let's try it out. For example, guys, I wanted the electron configuration for phosphorus, P. Okay, so go look for phosphorus, P. If you look at the periodic table, P is right here. Okay, see it? So let's highlight that box. That's our target box, don't forget. So how many electrons does P have? So again, the formula is atomic number 15 minus the charge. There is no charge here, so that it's 0. So this is now 15. So I got 15 electrons. All right. So again, I have to go box per box, starting from number 1 all the way to number 15. So again, Box number 1 is not shaded, so I don't write that. Okay. Box number 2 is shaded, so I need to write that down. So it's going to be 1 is 2. Okay. All right. How about box number 3? It's not shaded. Box number 4 is shaded, so yes, I need to write that down. 2 is 2. Okay. Box number 5, no. 6, no. 7, no. 8, no. 9, no. 10, yes. Okay. So I need to write that down. 2P6. Okay. Box number 11, no. Box number 12, yes. And that is 3S2. Okay. 13, no. 14, no. 15, wait a minute. 15 is our target box. So I need to write that down because that's P right there. So I need to write down 3P3 because this is the electron configuration inside that box. And again, guys, if you add up all the exponents, it should give you guys our atomic number. Okay. It should give you our number of electrons, which is 15. All right. Okay. Let's try it out, guys, for ions. All right, you all look closely at this one right here. This is going to be for ions. What if it's O2 minus? Okay, you all look closely at O2 minus. Okay, so the first thing you need to figure out, guys, is where is O? Okay, O is right here, right? All right. Okay, but wait a minute. Look, the atomic number of O is 8. Okay, 8. You see it? Minus the charge, which is minus 2, gives me 10. Okay, so guys, instead of 8 being our target, your target is actually 10. Okay, is that clear? So again, guys, although oxygen is 8, do you all see it? So again, although oxygen is 8, oops, sorry, although oxygen is 8, since it has a charge of negative 2, okay, since it has a charge of negative 2, that increases our number of electrons to 10, which means instead of O being our target box, we look at 10. All right, see it? So again, guys, you're looking at your atomic number as your target, not actually the element inside. So don't forget that, all right? So again, this is O2 minus. See it? So again, this is O2 minus right there. Let's make that red so you can see it. So this is O2 minus. That will be the box for O2 minus. All right. And you still follow the exact same thing. You just start from the very beginning. Box number 1, do we write it down? No. Box number 2, look at it. It's shaded, so yes. So therefore, I need to write down 1S2. All right. Box number 3, no. Box number 4, it's shaded, yes. So therefore, I need to write that down. 2S2. Okay. Box number 5, no. 6, no. 7, no. 8, no. 9, no. 10, yes. And therefore, that's our target box. And that's going to be the last one, 2P6. And again, guys, if you add up all the exponents here, so again, if you add up the exponents, which is 2 plus 2 plus 6, this should give you 10. All right. So again, guys, if it's if it's an ion, guys, all right, if it is an ion, you have to take note that the charge, okay, changes the number of electrons. So O2 minus, okay, is also the same as the electron configuration for Ne. You see it? So again, so be very careful of that. Let's try it out one more time. So for example, guys, let's take for example Ca2 plus. No, let's do Mg plus 2. Mg plus 2 or 2 plus. Remember, guys, we said Mg, look for Mg is right here. Mg is right there. Okay. And the atomic number for Mg is 12. Okay. 12, but there's a charge which is positive 2. So 12 minus positive 2 gives me 10. Oh, wait a minute. We just did this. Okay, which means, again, 10, our target is box number 10. Box number 10, atomic number 10, which is right here. Okay, So again, this will be the same as Ne. Okay, so again, this will be the same, okay, as Ne. All right, and we can now do it. So let's start with the very first box. Box number one, it's not shaded, so don't worry about it. Okay, box number two is shaded, so check. We need to write that down. So that's going to be 1s2. Box number three, not shaded. Box number four is shaded, so write that down. 2s2. Okay. Box number five, no. Box number six, no. Seven, no. Eight, no. Nine, no. And again, 10 is our target box. So you write that down. 2p6. All right. You see it? All right, guys. What we've been doing, guys, is the electron configuration in the standard form. Okay. So again, this is called the standard form. Okay. Standard form. Okay. All right. So what if we wanted to write this down in the abbreviated form? All right. So let's write some examples of that. So we're going to take an example and write it down in both the standard form and the abbreviated form. All right. So let's take, for example, let's do silicon. So Si. All right. So we're going to do Si. All right. Si. Okay. Look. Whereas Si is right here. And if you look closely, the atomic number is 14. So it's 14 minus the charge. There's no charge, therefore it's 0. And this is 14. So you got 14 electrons to distribute. So since 14 is the number of electrons, box number 14 is our target. It's the same as that Si. All right. So first of all, guys, we're going to do what you call again the standard form. All right. So let's write it down the standard form, the way we always do. Okay. So standard form. Okay, so again, how do you do the standard form? You always start from the very beginning and look at shaded boxes only. So, one, no. Okay, box number two, yes, it's shaded. Therefore, I have to write it down. So it's 1s2. Okay, box number three, no. Box number four is shaded, yes. So I have to write that down. So it's 2s2. Box number five, no. Six, no. Seven, no. Eight, no. Nine, no. 10 is shaded, so yes. Write that down, 2p6. Okay. Box number 11, no. Box number 12 is shaded, so let's write that down, 3s2. Box number 13, no. Box number 14, wait a minute, that's our target, so I need to write that down. It's 3p2. All right. So that's the standard form. Okay. The question now is what if you want the abbreviated form or what you call the noble gas configuration? All right. I'm going to write it down here. Hopefully, you all can see it. Okay. This is called the noble gas configuration or this abbreviated form of writing down electron configuration. All right. Guys, as the name goes, all right, to find the noble gas configuration, okay, you still do the same exact thing. You look for your target box. Let me erase everything. Okay. Oh, let me erase first everything. Okay. So it's the same. You start off the same way. You look for your target box, box number 14. Okay. But instead of writing it down, guys, starting from number one. So again, instead of writing it down, starting from number one, going through number one all through 14, what you do is you look for the closest noble gas before it. So what are the noble gases? The noble gases are the last column in the periodic table. This column right here. So these are noble gases. So you look for the closest noble gas before it. So in our case, our closest noble gas before it is neon. So again, 14. You just backtrack. So 14, 13, 12, 10, and will be 10 is your noble gas. So you just go back. So again, you look for the closest noble gas before it. So in our case, it's neon. So it's going to be Ne. I'm going to write that down, guys, in brackets. Okay. I'm going to write that down inside a bracket. All right. And that's going to be my new starting point. Instead of starting from box number one, you just start at that noble gas right there. So We just wrote that down, so you just continue. So we wrote down already box number 10, continue on to box number 11, and follow exactly the same rule as before. You only write down shaded boxes plus your target box. So box number 11 is shaded? No. Box number 12 is shaded? Yes. Okay. So this will be 3S2. Okay. Box number 13 is shaded? No. Box number 14, that's our target box. So we need to write that down. So that's going to be 3P2. You see it? Okay. All right. So why do we need to look at the noble gas configuration? Well, number one, it's a shorter way of writing it. And number two, guys, the exponents that you're going to see, for example, this is 2 and 2, actually tells you the number of valence electrons. So this one right here has 4 valence electrons. And we're going to learn more about valence electrons when we get to the Lewis dot diagrams and when we get to families. All right. So again, don't forget, that's the reason why we look at the noble gas configuration. Let's try it out again. All right. So let's try it out again. So we're gonna write it down both again in standard form and in noble gas configuration. All right. So let's take for example, let's take something like nitrogen. Let's take something simple. N. All right. So look for N. N is right there. Okay. See it? All right. So atomic number is 7. So this is 7 minus the charge. There's no charge. This equals to 0. Therefore, this is 7. See it? So again, we need to look at box number 7. And in our case, it's that same box. It's still for N. Okay. You see it? All right. So again, we'll do first the standard form. Again, this is the standard form or the standard configuration. Okay, we'll call it the standard E configuration. Okay, I'm just lazy at writing down electron configuration, right? So again, always start from box number 1. Box number 1 is not shaded, so no. Box number 2 is shaded, so yes, this is 1s2. Okay. Box number 3 is not shaded, no. Box number 4 is shaded, so check. So this will be 2 is 2. Box number 5 not shaded. Box number 6 is not shaded. Box number 7 is our target box. So yes, therefore it's 2p3. See it? All right. And again, you can check if you add up all the exponents, it gives you exactly the atomic number. All right. So let's check. So this is 2 plus 3 and gives me 7. All right. So let's now do the noble gas configuration. Noble gas. Okay. So again, noble gas configuration. And how do you do this again? All right. Noble gas configuration. Let's erase all our x's and squares again. All right. So again, same as always, just look for your target box. Okay. In our case, it's number 7. And then you have to look for a noble gas before it. So again, the noble gases are the last column in the periodic table. All right. So again, the last column in the periodic table. So it's this column right here. Okay. So again, it's this column right here. So I need to look for a noble gas before, not after, right? It's before our target box. So 7, just go backtrack until you hit that last column. So 7, 6, 5, okay, 4, 3, and then 2 will be our noble gas. You see it? Okay, so again, that's going to be our noble gas. All right. So again, the first thing you need to do is write that noble gas inside brackets. Okay. And then continue on from that box. That's going to be your new starting point. You're not going to start now from box 1. You're just going to start from that noble gas and then move forward to your target box. Since we already wrote that box, that noble gas, continue on to the next one. Box number 3, it's not shaded, so you don't write it. Okay. All right. Box number 4 is shaded, so we write that down. So this 2 is 2. Okay. Box number 5, again, it's not shaded. 6 is not shaded. 7 is our target, so we have to write that down. It's going to be 2p3. See it? And again, guys, if you add up all the exponents here, the 2 plus the 3, this should give you 5, which is your valence electrons. Okay, valence electrons. All right, y'all see it? Cool. Okay, let's try one that has a charge. All right, because a lot of people are confused about it when they have a charge. Okay, remember, guys, none of the elements on the periodic table have a charge. There's nothing there with a charge. Nothing. Okay, nothing at all. So, for example, let's take, for example, in a positive. Remember, positive is positive 1. Okay, so if you look for Na is this box right here, box number 11. So, atomic number for Na is 11. But wait a minute, remember, to get the number of electrons is atomic number minus the charge. In our case, it's positive 1, and therefore we only got 10 electrons. So therefore, our target box is not that box. Okay, it's box number 10, so which is this box. Okay, do y'all see it? So again, it's that box right there. Okay, so our target box is that box right there. All right. Okay, which means, hey, it's the same as, so this is actually the same as Ne. So don't forget, this is the same electron configuration as neon. Okay, all right. And then let's do the standard form. Okay, I'm gonna write down standard in that way. Okay, so again, start from box 1. It's not shaded, so no. Box number 2 is shaded, so yes. So this will be 1s2. Okay, all right. Box number 3, no. Box number 4, yes. So this is 2 is 2. Okay. Box number 5, no. Box number 6, no. Box number 7, no. Box number 8, no. Box number 9, no. Box number 10, yes. That's our target, so it's 2p6. Okay. See it? So again, if you add up, guys, all the exponents, it's going to give you your, okay, it's going to give you your atomic number. All right. Cool. See that? All right. Okay, let's talk about its noble gas configuration. All right, noble gas configuration. Okay, all right, guys. If you look closely, guys, for ions, all right, and this is the, so let's erase everything. If you look closely, guys, at ions, well, actually, in noble gases. Okay, for example, look at our target box. It's already a noble gas. All right, you see it. So again, guys, it's already a noble gas. So our noble gas configuration can either actually just be, I'm sorry, I erased that. Okay, you can actually just write it down as Ne. Okay, which will give you, which is also correct. Okay, why? Because this actually shows that when you lost that electron, you're left with a full shell. Or if we follow the old rule, okay, and if you follow the old rule, you have to go look for the element before it, okay, the noble gas before it, which is He. You see it? All right. So I need to go backtrack and find the noble gas before it, which is He. All right. So I'm going to start from that He. This will be my new starting point. All right. And then continue on until I get to Ne. So Li, no. Be, yes. I have to write that down. 2s2. Okay. 5 no, 6 no, 7 no, 8 no, 9 no, and then 10 yes. Then this is 2p6. All right. So wait a minute. So which one is the correct answer for noble gas configuration? This one or this one? Okay. Actually, they're both correct. All right. So for our tests and quizzes, most of the time I will accept both. Okay. They are both accepted as correct because the first one, that just the Ne, shows that when you lost that electron, you're left with only a full shell, okay, underneath, okay, and you have an empty shell on top, basically where the electrons can, where bonding can happen. All right. The second one shows that it's a full shell, okay. The you have 8 electrons in its outermost shell, which makes it very stable. All right. So hopefully you learned today how to do the standard form and noble gas configuration for electron configuration. All right. If you have any questions, just ask me, and I'll see you around.